In this segment, we're going to look at the Earth and Venus atmosphere and compare the two atmospheres. In this diagram from your textbook, we have altitude increasing on the vertical axis on your left, and therefore ground is at the bottom and sky is at the top. On the horizontal axis, we have increasing temperature to the right. Therefore, hotter temperatures are on the right and colder temperatures are on the left. Now let's focus only on the blue line in the scale. Let's look at how the temperature varies as we go from ground to sky on the Earth. So notice we start out getting colder, and then we start to get a little warmer, and then we go really cold, and then we get really warm. Well, what's going on right before this first bend, where the temperatures get colder as you increase in altitude? Well, the atmosphere from ground to where that first bend is called the troposphere on the Earth. And this is where all the weather is. So I'm going to draw some little clouds. They look like dots, but pretend they're clouds. So the troposphere is where the weather is occurring, where it rains or where it hails. Weather occurs in the level below the cloud levels in the troposphere. Now what's going on in that next level, where we see that next bend? Well, this region of Earth's atmosphere is called the stratosphere. And the stratosphere is where airplanes fly. So I'm drawing myself a little airplane. So it looks like a fly, but pretend it's an airplane. The stratosphere is where your commercial airlines fly. And if you notice, if you ever left from ground flying in an airplane in a commercial airline, you go up into the stratosphere and you notice that you might get cold on the plane. Well, the temperature decreases as you go from ground up through that troposphere and into the stratosphere. But if you went even higher, the temperature would increase. So what's going on to the next bend? The next atmospheric layer is called the mesosphere. In the mesosphere, that's where aurora occur, the northern lights or the southern lights. So we'll put aurora in that region of the Earth's atmosphere. That's the mesosphere. And notice the temperatures decrease as you go up in altitude through the mesosphere. And then finally, at the top of the mesosphere, notice the temperatures drastically start to increase. This is called the thermosphere. The International Space Station is located in the thermosphere of Earth's atmosphere. And I'll label that as ISS. Technically, the ISS is way up here. It's around at an altitude of 300, 400 kilometers. Now notice on the Earth that the cloud structure is located at an altitude of around 10 kilometers. Now let's go look at Venus. When we look at Venus, the cloud structure is located at 50, 60, 70 kilometers above its surface. So notice the difference between the cloud structure on the Earth compared to the cloud structure on Venus. The cloud structure on Venus is more than 5 times higher in altitude than the cloud structure on Earth. Now this is a UV image on the upper right of the atmosphere of Venus. So even though it's ultraviolet, you can see that there's a very thick layers of clouds. You can't see down to the surface of Venus. The clouds are so thick that they completely hide the surface of Venus. The light that reaches the surface of Venus is deeply reddened. So imagine standing on the surface of Venus and seeing red everywhere, like a red sunset or a red sunrise. Everywhere is this filtery, thick red clouds. And so you see just reddish light. Now let's return back to the diagram. Notice once again where the clouds are located on Venus. If we compared to the structure, the atmospheric structure on Earth, the clouds would be in the mesosphere of Earth, where the aurora occur. So if we were on the surface of Venus and we had all this reddish light, and then we looked up, and if there was a magnetic field on Venus and there were aurora occurring, it would be blocked by all the clouds. We would not be able to see the aurora in the sky. Even worse, there would be airplanes that would be flying around on Venus, and the cloud structure would be so thick we wouldn't even be able to see the airplanes flying in the sky. Now let's look at the temperature structure of Venus as we go from ground to sky. So let's look at the red line. First thing I want you to notice is where the red line meets the axis. The temperature on the surface is well over 700 Kelvin. That's more than double the temperature on the surface of the Earth. It is very hot on the surface of Venus. But as you go up in altitude, you reach where the cloud structure is, you reach an actual decent temperature. Notice where the cloud structure is in the altitude, the temperatures actually pretty much mimic the same as Earth and the same altitude. But then as you increase even further, the temperatures pretty much stabilize at minus 200 degrees Fahrenheit, whereas on Earth you are climbing in this thermosphere. So we see that Venus's atmosphere doesn't have a thermosphere. We don't see a bend of this line. We don't see a bend of this line to the right. It doesn't exist. So possibly there is no thermosphere on Venus. So where would we put the troposphere and the stratosphere and the mesosphere and the thermosphere, if possible, on Venus? Well, let's erase our diagram. Remember, the troposphere is where the weather is. And so since this is the top of the cloud structure, we would say everything below this would be the troposphere on Venus. And then above the troposphere is where the airplanes would fly, and that is the stratosphere. So since the temperatures are relatively constant here, this would be the stratosphere. No, there is no mesosphere. We don't see any change in temperature getting cooler, and we don't see any change in temperature getting warmer like we do in the case of Earth. And so there is no